of Algebra 1, and I gave you guys some pretty difficult problems this morning, okay? This is slightly more advanced than what we were doing yesterday. I just wanted to throw it out and see who could do it. So, before we go through how to solve all of them, I would like to go through each problem and just write down all the different answers we got, because I'm sure we got multiple different answers. And then we're going to figure out which one of those answers is the correct one. So for number one, let's see, the problem that I have written here is x plus 1 divided by 10 is equal to -1. What are some answers that you guys got for x?
-11.
-11. Anything different than that? Every person got -11? Okay, if you didn't.
Oh, no, you must, don't worry about me. I didn't do none of it.
That's okay. That's okay.
My mind ain't, it's gonna take a while to keep.
That's okay. Did anyone get something different than -11? If you did it. Okay, moving on. Let's look at number 2. Anybody attempt number 2?
-2.
-2. Did you get +2? Okay, so we got 2 answers for that one. -2, +2. Anything else?
3.3 repeated.
3.3 repeating?
Mhm.
Okay, let's put that one down. 3.3 repeating. Okay. Any other answers or just those 3? Okay, let's look at number 3. -6 equals x divided by 2 plus 2. What answer did we get for this one?
I got -16.
-16. Anything different?
-10.
-10. Anything else? Everyone got -16 or -10 if you did it?
60.
Perfect. Okay. How about number 4? This one's pretty crazy.
-5.
Okay, -5.
I got -75.
-75. Okay. Anything else? -5, -75. Any different answers if we tried it? Okay. Number 5. What answers did we get for that one?
4.
4, just +4. Okay. Anything else? All right, last one. Number 6. What did we get for that?
13.
13. Any different answers than 13? Good morning. Come on in. Anything different than 13 for number 6?
I got 13.
Okay. All right. So let's go through each of these and see what the answer might be. So for number 1, who would like to tell me what I should do first?
Multiply 10 by both sides.
Okay, so multiply both sides of the equation by 10. That is correct. How do you know to multiply both sides by 10?
Because it's dividing.
Yeah, we have this side of the equation being divided by 10, and we need to get rid of that. So to get rid of division, we do the opposite, we multiply. So let's multiply this side by 10. And we're going to multiply the other side by 10. And before we go to the next step, is anyone unsure how we knew to multiply by 10? Or do we feel okay about that? So we're multiplying both sides by 10. What happens to this side of the equation?
Cancels.
It cancels. My 10s are going to cancel out. And that's going to leave us with just x plus 1. So we'll bring that down. X plus 1. And we need to bring everything else down. We'll bring down our equal sign. And what happens on the other side of the equation?
You multiply -1 by 10.
Yes, we're going to multiply -1 times 10. And what is that going to give me?
-11.
-10.
Oh.
Oh, were you thinking of adding it?
Yeah.
That's okay. Yes, if you take any number times -1, it'll be the same number, but negative. So we've got x plus 1 equals negative 10. Okay. Oh, you were doing the last step already.
Yeah.
I get you now. So what is that last step? What do we do here?
Subtract 1.
Yes, our goal is always to get x by itself. There's a plus 1 over here with it. So to get rid of it, we do the opposite of plus 1, which is minus 1. So let's subtract 1 from both sides. It's going to cancel my 1's out. And I'm going to write my answer a little further over. That leaves me with x is equal to negative 10 minus 1, which is, yes, negative 11. Good. Good, good, good. If you were unsure at first how to solve number 1, now that we see it all written out and we've gone through the steps slowly, does it make sense now? Does it make a little more sense? Or do we have any questions still about it?
Can you go back up there to the top, can you go back up there to the x plus 1 over 10?
Yes,
Just
absolutely.
explain that. Just explain
Yes.
it again.
So let me grab a sticky note and I'm going to rewrite it so that we're not looking at too many things at once. So I have x plus 1 over 10 equals negative 1. So anytime we have something over a number, that line in between is telling us that we are taking whatever this is divided by 10. And we want to get rid of 10. So anytime we want to get rid of something in an equation or cancel it out, we're going to use the inverse operations, the opposite. So we know that we are dividing by 10 originally. So the opposite of division is what? Multiplication. Good. The opposite of division is multiplication. So I'm going to write that by just putting it all in parentheses and I'm taking it times 10. And whatever you do on one side, you've got to do to the other. And that would cancel it, bringing us to that next step where we just have x plus 1 equals negative 1 times 10, negative 10. That's what we are left with. Does that clear it up a little more?
Yeah, I just.
Okay, perfect. Any other questions? Okay, do we want to go on to number 2? Okay, let's do it. This one was really tricky. Really, really tricky. We have a lot of things going on here, okay? We have 2 right next to a quantity in parentheses, x minus 2. That's just one side of the equation. Then on the other side, we have more variables, 8x minus 16. So when we have a lot of different operations happening, it looks like there's going to be quite a few steps to this one. How do we know what to do first?
Parentheses.
Yes, you're going to do the parentheses first because that's what the order of operations tells us. Remember, we have a poster that tells you up here, order of operations. That just tells you what order do we do this problem in. So parentheses comes first. And right here, I've got some parentheses. So whenever I have a number outside of something in parentheses directly next to it, what operation is happening here? What are we doing?
Distributive multiplication.
Yes, we're going to distribute this 2 by multiplying by both of the terms inside the parentheses. So I like to show that with arrows. We're going to be taking 2 times x and we're doing 2 times 2. Or you could think of it as negative 2. So let's go ahead and do that part first. What is 2 times x?
2x.
Good, 2x. And then we could carry down that negative sign. 2 times 2, 4. Wonderful. All right, so we have done that. We distributed. What do I need to do next?
Bring down the.
Yeah, we're just going to bring everything down. Equals 8x minus 16. So now we have a new equation. Whenever we have variables on both sides of the equal sign, what do we need to do first? We're going to combine them. We need to put our x's together. We need to make sure that it's all on one side. So, what do you guys think would be the smartest choice to do with this equation?
Subtraction.
Subtract 2x. Good. We could have either subtracted 2x from both sides, or we could subtract 8x. But if I subtract 8x, I'm going to end up with a negative x over here. So I always like to work with the smaller number attached to the variable. So let's do what you just said. Minus 2x on both sides. Okay. And what happens next?
Plus the twos.
Cancel out the 2x. Good. And then what?
Bring the rest down.
Yeah, let's bring the rest down. So what am I bringing down exactly?
-4.
Good.
6x minus 16.
Perfect. -4 equals 8 minus 2 is 6, so 6x minus 16. Perfect. We're just working on the do now right now. We're just going over answers. Okay. Now we have a whole nother equation. My goodness. This is more than a 2-step. This is a lot of steps. What would we do next?
Add 16.
Yes, add 16. We're going to do that on both sides of our equation. And I saw a bunch of people erase just now. Did we do something different? They did.
I wrote the problem down wrong.
That's 4.
You did the 4. Oh, you added 4?
Yeah.
Okay. Did anybody else add 4 at
I
this
did,
step?
Yeah.
Did too.
Yeah.
It's super tempting to want to get rid of a negative number that's smaller, since we normally do that with variables. But once we have our variable terms combined, what we're trying to do now is that original goal of getting x by itself. So if we want to get x by itself, we can kind of think about it and reason, if I get rid of 4, it's going to get rid of it on this side, but it's just going to add more to the other side with my x. It's going to get x even more surrounded by things we don't want. So we're going to do the 16. And what happens when I add that 16 to both sides?
The 16.
Yes, it's going to cancel out my 16s. And then what would I do?
12 equals 6x.
Good. -4 plus 16 is 12. We'll bring down our equal sign. And 6x. Okay. So, I did not give myself enough room. But now we have 12 is equal to 6 times x. What would we do now?
Divide.
Yes, we want to get x by itself. We just have one last step. We're going to divide by 6 on both sides. So let's do that. See what I can do. Divide by 6, divide by 6. I apologize. This is some of the worst looking work. Okay, so this is not making it easy for us to tell what's going on here. I'm sorry about that. We did 6x divided by 6. That gets rid of our 6's. We will have x by itself. We'll bring down, flash up our equal sign. And what is 12 divided by 6? 2. So,
Did my problem different? Got percentage.
what did you get? Did you get the negative 2?
No, I got the positive 2, but I did mine.
Oh, how did you do it? Here, I'll get a sticky note. Well, I want to compare your method because I love that you can do things differently sometimes and get the same answer, because some of our brains work differently and we're going to say a different method. So I'm going to rewrite that problem. 2x minus 2. Okay, so what did you do?
So I started with those parentheses.
Okay,
So I got 2x minus 4,
okay.
and then brought everything else down.
Brought everything else down. So you started with the same steps as us. And what did you do next?
I added 4 to both sides.
Oh, okay. So he added 4 to both sides this time. Here is where you can do things in a different order as long as it's not, trying to think of what is the as long as. As long as you're putting it, as long as you're doing addition and subtraction, that's what I want to think of. You want to do any addition or subtraction first whenever we're solving equations. Just like over here, we added, where did we start? Or we subtracted first. We subtracted 2x. We did the x's. Those were like terms. If you remember, we talked about that yesterday. They have the same variable. And that didn't affect the 4 or the 16, or the -4, -16. Over here, if I decide to work with the numbers without variables first, is it going to affect the variables and change my answer in any way?
No.
It won't. It won't. You're still just doing addition and subtraction first, and we're combining like terms. We're just looking at the terms without variables. So let's see. You added 4 to both sides. Add 4. Okay, and that canceled out this. So then what did you do next?
-16 plus 4 is -4.
-12.
And then I brought everything
Brought
down.
everything down. Now we have 2x equals 8x minus 12. And let's compare over here. If you notice, what we have going on is on this equation, when we solved it, it's like it's flip-flopped. We have our, let's see, our 8x and our 2x. We just moved. So your answer, did it end up being x equals 2 instead of 2 equals x?
Yeah.
Okay, let's finish the rest of it out. It might make more sense. So what did you do next?
I subtracted 8 from both sides.
Yeah, okay, so minus 8x from both sides. Okay, that canceled it. What's 2 minus 8?
So -6.
Okay, so this is where our answers look different. We have -6x equals -12. We had 12 equals 6x. By doing it this way, you will get the same answer, but you see that we have a different set of work here. Now we have negative numbers we're working with, which is fine. I always try to avoid negative numbers because I know it confuses some of us, but it is still a valid, correct way to do it. It works. So what did you do lastly?
Divided -6 both sides.
Yeah, so instead of dividing by 6, you would have to divide by -6. And we would see that would cancel. We'd have x equals, and those two negatives would cancel each other out, giving us the same answer of x equals +2. So there's multiple ways you could go about doing it. If this confuses you though, feel free to just continue to do it the way that I've been showing you. I think sometimes when we're not quite to that understanding of all the different things that we have options for yet, sometimes it feels easier to just kind of follow the guide and say, okay, I know I combine like terms first, I'm gonna just do that first, and that will work for you too. But if you've got, this takes a really good understanding of math, so the fact that you were able to do that, that's really awesome. Awesome. Any questions? Any questions at all? Does anybody still need this work up here for number 2? Let's look at number 3. Have -6 is equal to x divided by 2 plus 2. What should we do first?
I multiplied 2 by both sides.
Okay, so you multiply both sides by 2. Can we do that first?
No.
Why not?
I subtracted it.
So let me give you guys a quick reminder. Whenever we are solving an equation and we're using our inverse operations, we're also using the opposite order of operations. So whenever we are not trying to solve an equation for a variable, for x, we would, if I solve, let's see. If I had a problem like 2 times 4 minus 2, we would look at the order of operations and say, okay, I'm going to do parentheses first. And then I guess I could do 4 minus 2 because it's in parentheses, or I could do multiplication first because that's what the order of operations tells me to do. But whenever we are solving an equation, we want to do it in the opposite order, meaning first, we cancel out any addition or subtraction. That's the first step. Once we've gotten rid of all addition and subtraction, then we can do multiplication and division. So we're doing it in the opposite order that we're used to. So we know we need to do addition and subtraction first. We're going to subtract 2 from both sides first. And is everybody okay with that? So minus 2, minus 2. And that's going to cause my 2's to cancel. And what happens next?
Get -8.
Good. -6 minus 2 is -8.
Then bring
Yes, bring everything else down. Equals x divided by 2.
by 2 for both sides.
Good. Now we do that step. Now we multiply by 2. My 2's cancel. I'm left with x equals, what is -8 times 2?
-16.
Oh, -16. Be careful. We are multiplying here, not dividing. -8 divided by 2 would be -4. But -8 times 2 is -16. So I bet whoever got -10, did you do the multiplication first? Let's see if that's what it would give us. Let's see. So if I had, I'm going to show you an incorrect way. So if this is going to confuse you, feel free to zone out for a minute. I am going to multiply by 2. This is not correct. Let's see, that would give us -12 equals x plus 2. And we would actually have to multiply this by 2 as well. It would become 4. But we see that that's not going to work. -2 minus 2. That would give us -14. Interesting. I don't know. I wonder how somebody got -10. Maybe they
Added.
thought 12 minus 2 is 10 and it's negative.
I think they added 8 into. Cause that would
Added
give it,
8 into. Where's 8?
we took 8 times 2, I think they added it. That would make 10. Other side, the actual problem that we did.
Oh, I see. That makes sense. Okay, I see. So whoever got -10 must have done -8 minus 2. I see. Okay. All right. Any questions on number 3?
Yeah.
Sure.
I kind of got confused because, we divided both sides to 2 first and then multiplied it, so.
So let's see. At which point?
At the bottom.
Okay.
Right in the middle, right there. So you
Here?
see how we have the x over 2, which is division, and you flipped it over to multiplication.
Yes, so it's whenever we're solving, we're using the inverse operations, the opposite ones. Just like here at the beginning of the problem, we wanted to get rid of +2, so we did -2. Down here, we have x divided by 2. So to get rid of divided by 2, we need to do the opposite, which would be times 2. We're just always doing the opposite. Does that answer your question, or am I misunderstanding your
No,
question?
It's answering my question. I'm probably just waking up, but
You're okay.
yeah,
You're
it kind of
okay.
confused me over 2, right?
Do you think it's because I wrote the 2 out to the side
Maybe so.
rather than writing like times 2 under it?
Mm.
Okay, so I've been trying this term to change the way I write multiplication and to get you guys used to it as well, so that we know anytime we see parentheses and a number, this will always be multiplication. If I see this, just like the other side of my equation, and a number 2, this means we're multiplying by 2. The reason I haven't been doing this as much is because I worry that seeing the multiplication symbol as an X, we're going to mix it up and confuse it for another variable, and mess up our answers. So it is definitely different than what we might be used to. It's going to be a little bit of an adjustment for all of us, but I think it's going to really help us in the long run if we can try not to use the X as the multiplication symbol. I've just seen so many, I've done it myself, mixing it up for a variable, pretending it's an X. Does that help a little too?
Yeah.
Okay. Any other questions on 3? Okay, let's look at number 4. This one's crazy too. Honestly, now that I'm like looking over all these, I feel like I'm being mean to y'all this morning. I'm sorry. If you've gotten all these, that's amazing. Congratulations, because this is very challenging. When we're looking at number 4, what are we thinking? I mean, what are we thinking? What's going on here on this side of the equation?
You gotta do the multiplication first.
Yeah. So normally whenever we're solving an equation, we're always doing the addition and subtraction first, and then the multiplication and division. So over here, there's really nothing we can add or subtract. There's nothing that we can add or subtract because this is inside parentheses. So whenever we have that, like a distribution in our problem where we have 2 times 4x and 2 times -8, we need to do that first. We need to get rid of our parentheses first. So I'm going to rewrite this and give myself more room because I know I'm not going to have enough room on here. Number 4. Give me just a moment. We're going to write -91 equals 7. 2. Okay, so you said we're gonna do this multiplication part first, correct?
Right.
Okay, so let's draw our arrows. We're doing distribution. We're multiplying 2 times 4x. We're multiplying 2 times -8. So what is that gonna change these numbers to?
8x
Mhm.
minus 16.
Good. 8x, 2 times 4x is 8x, and then 2 times 8 is 16. We can drop down that minus sign, or we could think of it as 2 times -8 gives us -16. Before we go any further, Anyone confused about what we just did? What do we do next?
You add the 7 to 8.
Yes. Oh, yes. Okay, so let's bring everything down. That's what I'm assuming you did first. Let's do that. We have 7x plus 8x minus 16, and we still have negative 91. Okay, so you said we're going to add 7x and 8x together, right? How'd you know that we could do that? Yes, they have the same variable. These are like terms. Whenever you have like terms on the same side of the equation, you don't have to use inverse operations. I'm not combining them on opposite sides of the equal sign. They're already together, so we can just add them. 7x plus 8x is what? 15x.
Could you go on it like another way? Do you have to do that part, or is like, could you do like minus 16?
You could do it other ways too. You could get rid of the 16 first. Absolutely. Absolutely you could. So we have 15x now. And what next?
Drop it down.
Bring everything down. We still have minus 16 equals negative 91. Okay. So now what?
I added 16.
Add 16. Yes. The 16s would cancel out. Yeah, now let's bring everything down. I have 15x. I have equals, and negative 91 plus 16.
Negative 75.
91 plus 16. Negative 75. Perfect. Now, before we move on, being able to type that in your calculator is important. Does anyone need a kind of a run through again on how to type in negative numbers or anything like that?
No.
Or do we all feel like we know how to do this? Okay. Okay. We have one last step to do. What do we do?
Divide 15.
Good. We're going to divide by 15 on both sides. 15's cancel. Left with x by itself
Negative.
equals negative 5. Good. Very nice. Very, very nice. And I see the other answer that we have written down. The same. We had negative 5 and negative 75. So I wonder, I bet,
subtracted.
yes, I had a feeling that's what you
That's
did.
what
So
I
did you
did.
just do 8x minus 7x?
Yeah.
Combine them? That is very common, especially because, and honestly, that's on me. Yesterday, we did not go over what to do with like terms when they're on the same side. So I'm sure there are other people that got that same answer. But if they're on the same side, you can just add them like normal. Okay. Do we have any questions, or is there any part of this equation anyone would like me to go over again? Anyone still need this work? I move it? All right. 5. Okay. Number 5. Negative 8 plus 10x equals 32. What comes first?
Both.
Mm-hmm. Add 8 to both sides. This one's not as insane and intense as the others. What happens next?
Bring down the X.
Good. Let's bring down our x's. We have 10x. Bring down equal. 32 plus 8 is 40. And there's one last step.
Divide.
Good. Divide by 10. And 40 divided by 10 is 4. Good. Looks like everybody that attempted that one got it right. So the 10's cancel. X equals 3 divided by 10 is 4. Okay. So writing, I'll give you just another second here. We ready for the last one? All right, last one. 127 equals 10x minus 3. What do we do first?
Add 3 to both sides.
Add 3 to both sides. Good. And 3's cancel.
30.
Yes, 127 plus 3 is 130. We'll bring everything else down. Equals 10x. And yes, thank you. We just divide by 10. So my 10s would cancel out. And what is 130 divided by 10? 13. Good. 13 equals x. Awesome. Do we have any lingering questions about any of this? Anything at all? Okay. It did. So that was a bit of a challenge today. Tricky. Some of y'all did amazing on that. And everybody as a whole, I appreciate your effort and I appreciate you guys, being willing to tell me when you're not understanding something. That's going to help us all learn. So today we are going to do a little more practice on these types of equations. And then we're going to introduce something new during the second half of class. Before we do more practice on these, I think sometimes, let me see, what time is it? It's 9:54. We've been doing this for about an hour. Let's give ourselves a break from that topic, come back to it, and I'm going to give you some notes. So if you take notes, which I suggest you do, go ahead and get your notes out. And we're going to start a page today. I'm going to title this. Quick. Algebra 1. This is Unit 1. This is day 3 notes. January 15th. So at the top of our notes, we are going to title this Inequalities. I find a lot of students really enjoy inequalities. I like them. I think they're kind of satisfying. We're going to talk about these today. I'm going to use some colors for this part of my notes. I'm going to use red and green. It's like orange on the screen, but it is red. So let me ask you guys this. Have you ever seen a symbol that looks like that? What does this mean? Does anyone know? Greater than. Good. What about a symbol that looks like Let me bring it down a little lower, give myself space. This. Less than, good. So just like we read from left to right, the way that we can remember these symbols is which part of it comes first when we go left to right. When I go from left to right this way, the big opening comes first. So this is greater than, because it's the bigger part that we see first. And similarly, when we go left to right here, we hit the small point first. So it's going to be less than, smaller than, not as big. What if I show you this symbol? Really similar, but slightly different.
Greater than or equal to.
Some of you know this. Good. This is greater than or equal to, meaning it can be either the exact same size or bigger. So let's label that. Greater than or equal to. And I'm leaving myself some space over here to draw a little picture. So if you're trying to copy your notes like mine, leave yourself a little space. And remember, if any of you ever want copies of notes for you guys to have, just let me know after class. I'm always happy to do that. And what do you think I'm going to draw next?
Less than or equal to.
Good. Less than or equal to. Same symbol, just with half of an equal sign under it. So let's do that. Is less than or equal to. So now we are going to draw some pictures. And I am going to use a ruler so I have a straight line. If you are wanting your lines to be super straight, you guys should all have rulers at your desks. But don't feel like you have to use a ruler. I'm just particular. And if you need a ruler and you don't have one at your table, just let me know. I've got extras around here somewhere. So what I'm going to do first is start with our greater than. And right beside it, I'm going to draw a nice line. Ends and a little tick mark in the middle. Now, this next part is optional, but I always like to do it because it just helps me remember. To the right side of my line, I put a plus because I know that as we go this way to the right, things get bigger, numbers get larger. And then we're going to write a minus sign on the left side because as we move to the left, the numbers get smaller. So whenever we have a statement of, for example, whenever we solve a problem, we'll get an answer that might say x equals 3, for example. If I have an answer that tells me x is greater than 3, there's a way that we can graph that answer on a number line. We're going to show it visually today. So before I show you, does anybody recall doing this? In pre-algebra, maybe.
Yeah.
Yeah, some of you do. Some of you, this might be totally brand new, and that is okay too. So, if you do remember, who can tell me what is the first thing that I need to do to my number line before I draw any circles or color anything? What do I need to do to label this?
Number 3.
We could circle it. That'll come next. We want to label the number first. So, if my number, for example, is 3, the first thing we do is we put 3. I want to show that this is the point we're going from. And then, Lisa, you are correct in saying that next we're going to circle it. So, this graph is basically showing us, or this number line is showing us all the numbers that x could be. X can be any number that's bigger than 3. So we circle 3. Do not color the circle in. Leave it open. Because we're not including 3. X can't be 3. It can only be bigger than 3. So to show that x is bigger than 3, we're going to shade all the numbers bigger than 3. Just like that. And that's how you do it. That's your graph. I think they're fun to draw, personally. So, you know, whatever you think. So next, we're going to do greater than or equal to. So I'm going to use the same number as an example. Next, we're going to do x is greater than or equal to 3. I'm going to draw another number line. Plus, minus. Wait for everybody to be ready. All right. So I'm going to ask you again. What is the first thing I should label on my line?
Number.
My number. Good. Which in this case is also 3. So I'm going to write 3. And just like last time, once we have our number labeled, we want to circle that tick mark. So let's circle it. But this one's going to be different. What do you think we could do to show we have x is greater than or equal to 3? So 3 is included. X could be 3.
Yeah, color.
Yes. We're going to color it in. We're going to shade the 3 in this time. This shows that x can be equal to 3. And then we're going to shade to show that it can also be any number bigger than 3. So we would go to the right to show that it is bigger. Just like that. So if there's no line under the symbol, open circle. If there is a line under your symbol, closed circle. And show that it's included. We'll continue making this guide. Let's go ahead and draw another line for less than. Is less than 3. Another way to remember that this one is less is that whenever you look at this symbol, first of all, you're shading in the direction that it's pointing in. If this was an arrow, it's pointing to the right, we shade to the right. If this is an arrow, it's pointing to the left, we shade to the left. The other thing that we could think of is that this less than symbol looks kind of like a tilted capital L, L for less than. There's all kinds of little tricks you can use to remember. So what do you think we're going to do to begin the less than graph? Yes, tick mark and a number. And then I heard somebody else say to draw a circle. That is correct. Now, whenever I'm saying that x is less than 3, can x be equal to 3? No, not in this case. So do I need to shade that in? No, leave it open. And then which direction do we shade? To the left. Good. There we go. We're just going to do the exact same thing on the bottom for less than or equal to. Draw one last number line graph. It will be the graph of x is less than or equal to 3. So what's going to be the main difference between the graph directly above it and the graph for less than or equal to?
Shading.
Yes, just the shading of the circle. Everything else will be exactly the same. 3 on the tick mark, shading to the left, circle on the tick mark. Only difference is we color the circle in to show that x can be equal to 3. We want to include 3 in the graph. So here's our little guide. We're going to use this guide to learn a little bit about inequalities. So does anybody need this page still, or are we all caught up? Okay, wonderful. So that's our guide. I am going to flip to the next page. We're going to start a second page of notes. So I'm going to title that, and we shall begin. And I'm going to title this page Solving Inequalities. First of all, we have been working for the last 2 days with equations. The only difference between an equation and an inequality is the symbol that we use. They're exactly the same. We're doing the exact same steps. So let's say I were to give you, let's see, 2x plus 3 is less than 13. Only difference is now we don't have an equal sign. We have a less than symbol. So I'm not even going to directly tell you what to do. I would like for you guys to guide me. How do I solve this? Good. First, we're going to start by subtracting 3 from both sides, just like we would if it was an equation. Minus 3, minus 3. Okay. My 3's cancel. What happens next?
Bring down your 2x
2x
less than
less than
10.
13 minus 3 is 10. Good.
You still grab.
On the 2x, is that what you're talking about?
Yeah, like you still put it over the line or whatever.
Yes, you would. Once we've solved for x, then we will. So what do I do next to get x?
Fine, too.
Good. Let's divide by 2. Okay. And that's going to leave us with x by itself. My 2's will cancel out. I've got x is less than, what's 10 divided by 2? 5. And let's get in the habit of circling our answers, just because as things get more and more complex in here, it's difficult to find them when there's lots of numbers all over the page. So circling your answer helps me out a little bit when I'm grading. And it's going to help you guys out whenever you're looking back at your notes and you want to be able to see what the answer was. So we just solved an inequality. Let's use what we just learned when we made that little guide, and let's graph this. Let's graph this inequality. So I am going to just directly under it draw kind of a shorter line. I'm going to do a mini graph like this. Draw your line, your plus and minus. And I'll give you a dash. Once you've got that line drawn, what do we need to label first on this graph? The 5, good. We're trying to show visually every number that x could be. So we want to put 5 there. And remind me again, what is this symbol? How do we read it? Less than, good. So if x is less than 5, how do we show that on the graph? Say it again. Go to the left, good. We are going to shade to the left. And we're going to circle, good. So this is the steps we take. We do the number, we do the circle, we do the shading. Number, circle, shade. So we have our number 5. We have our circle. And we said open or closed?
Open.
Open. Why is it open?
Not saying.
I mean, it's not less than.
It
Or equal
can't
to.
be 5. It's not equal to 5. It's only numbers less than 5. So then we shade to the left, just like you guys said. And that's it. You're just solving an equation and then drawing a picture. Not too bad. Let's do another one. How about see, I want to steal some questions from about 4x minus 9 equals -9. Oh, I didn't mean to write equals. Let's do less than or equal to. My bad, guys. I just got in the zone. got that copied down. What would we need to do first?
Subtract, or add 9.
Yes, yes. So add 9. Now which 9 are you referring to? The one next to 4x or by itself?
By itself.
The one by itself? So you
Well,
want
I mean, take the 9 next to the 4 and add it to the negative 9.
Yes. Okay, so we have -9 here. We have -9 here. Technically, I guess it doesn't really make a difference which one you do it to because you're doing the same thing. If I add 9 to both sides here, I'm gonna be adding 9 to both sides. If I do it here, it's still adding 9 to both sides. It's got the same number, so it was kind of not a great question that I even asked you. I didn't realize it. So we're gonna try to get rid of that 9. And what happens here? It cancels. So we get 4x, we're just bringing that down. And we'll bring down our symbol, less than or equal to, and what's -9 plus 9?
0.
It's 0. Is that okay? Can it be 0? It can. 0 is a number. 0 freaks a lot of people out, but it's a number. We can work with it. What would we do next?
Right.
Yes, we have 4 times x. To get rid of it, we divide. 5 by 4. Divide by 4. Fours cancel, and I'm left with x is less than or equal to what? 0. Is anybody confused about how 0 divided by 4 is 0? This is how I like to explain it. Division is just evenly giving out the same amount. So I think if I have $0 and I have 4 friends that I want to share my money with, how much money does each friend get? They get $0 because I have $0. So if you take 0 and divide it by 4 or divide it by 1,000,000, it's always 0. Always. Yes.
This might sound ignorant. Why if the -9 plus 9 cancel that, but not on the other side? It's the same equation.
No, that's an excellent question. Let's talk about that. I'm actually glad you asked because I bet you somebody else is thinking it. So I'm going to rewrite that. 4x minus 9 is less than or equal to -9. So whenever we add 9 to both sides, what's really happening, and the reason we cancel this out, is because on this side, -9 plus 9 is 0. So we would have 4x plus 0 is less than or equal to 0. All we're doing by canceling is just saying, I know that 4x plus 0 is the same thing as 4x by itself. So we're just not writing the 0 because it would just add an extra step. So anytime we cancel something out, we cancel it out usually because it's 0. And adding 0 to something or subtracting 0 from something doesn't change the number. Does that help clarify it a little for everybody? Is anybody still confused about that?
I just was confused on which side. I don't know what's going on with my brain this morning, but so you cancel out the side that's on the left, pretty much.
Basically, your goal is to get everything away from the x. We want this by itself.
Okay.
So the things that are making it not by itself right now is this and this.
Good.
-9 and 4. So we got to get rid of that, and then we divide to get rid of the 4. And that is something that I think the more and more practice we do, we get more and more comfortable with it. It will become more like second nature. But that goal is never going to change. We're always trying to get our variable alone by itself. So we've solved our inequality. We now have x is less than or equal to 0. So we'll circle it. That's our answer. And now let's draw the graph. And after we do this one, I'm gonna give you guys a break since it is gonna be the end of period 1. I'll want you guys to come back for period 2. But I'm gonna try to give you guys a break. 3 hours is a long time to sit and do math.
Don't even feel like it.
I know, right? It's crazy. It's crazy. So I'm gonna draw my line. Okay. My tick mark, my minus, my plus. And if I want to draw the graph of this inequality, x is less than or equal to 0, what is the first thing I need to label?
0.
0. That's my number. 0. So I'm just going to write 0.
Start with shape.
Yes. Then I circle my tick mark, and I heard you say it. We shade this one in. Why do we shade this one in?
Equal to.
Because there's an equal to part of our sign here. It's not just less than 0, it's also equal to 0. So we color it in to show that. And what direction do we shade? The left. Very, very, very good. All right. Beautiful. Okay, guys. So here's what I am thinking. Let's give you guys like 20 minutes. Just be back by say 10:40, close to 10:40, give or take. That's like 15:20. It could be 10:45. It's gonna be kind of a soft start. Not gonna be like right at 10:40 we're starting. 10:40 to 10:45 we'll get back to it. Take a break, take a breather, do what you need to do. If you want to stay in here, you're welcome to. Up to y'all. Right, I'll call it that. So we are back from our break. And I just passed out this worksheet. If you're not here and you're watching the video, there will be a copy of this in your folder in the classroom. But let's look at this together. So I'm going to start with number 1. Get it to focus.
Yeah.
Let's see. Okay. And I'm probably going to write my work under the number line so that I have some space. They don't really give us a whole lot of space on this worksheet. So, all right. Number 1, I have, and you'll notice our variables aren't just X on this worksheet. There's some different letters. Like for number 1, we have N. It'll be the exact same process. You'll just be writing N instead of X. Same exact steps. So I'm going to write N divided by 3 plus 2, my symbol, and 0. And what symbol is this? Greater than. Remember, we go left to right. We are hitting the big open side first. Greater. It's also pointing to the right, pointing to where the numbers get bigger. So I like to put my little plus and minus just to remind me. So looking at number 1, I see that I have 2 operations happening. I have N divided by 3. I have that plus 2. There's 2 operations. So which one should we do first? Yes, we want to get rid of the addition and subtraction first when we're solving. So what should I do to get rid of plus 2? Minus 2. Good.
Plus 2 then.
Minus 2 on both sides. Good. That will do what with my 2's? Cancel them. Good. So then we'll bring everything else down. Got N divided by 3. Bring down greater than. And what is 0 minus 2? Yeah, negative 2 minus 2 stays the same. Okay. So what would I need to do next to get n by itself? Good. We're just going to multiply by 3 times 3 on both sides. And what happens over here with the n and the 3's?
Cancel.
They cancel. The 3's are gone. And I'm going to write my answer over to the side here. So I have n by itself. And then I'm going to copy my symbol, keep it the same, still greater than. What's negative 2 times 3? Good, negative 6. So that's our answer for number 1. We're going to circle it. If n is greater than negative 6. So let's go to our graph now. I see they've given us a bunch of numbers. Which number am I going to be focusing on? Negative 6, the answer we got. So we're always going to start with labeling that number. It's already labeled for us. Next step, what are we doing? Circle. We're going to circle it. Circle that negative 6. And do we shade it or leave it open? Leave it open. It's not equal to negative 6. It's greater than negative 6. In what direction do we shade? To the right, towards the plus, where numbers get bigger. That would be your answer to number 1. I'm just going to write my answer above it. N is greater than negative 6. Ew. Okay, any questions on that number 1? Okay, let's see. How about this? Instead of just going in order, you guys take a moment and peek through these problems and tell me, are there any of them that you would like me to go over with you as a class?
4.
Number 4? Okay, let's look at number 4. All right, so number 4, I have 1 plus m over 9. This means divided by 9. And I'll bring down my symbol. Greater than or equal to 1. Okay. So this one can be tricky because we have one side of our equation all over a number. All of it's being divided by 9. So what is the first thing that we need to do to solve this? We want to get rid of this 9. And you're exactly right. We're going to multiply by 9. So why do we multiply by 9 to get rid of it?
Divide.
Yeah, it's the opposite of division. We're always doing the opposite. So to get rid of that 9, we're going to take this times 9. Same thing on the other side. Take it times 9. Okay. So what happens on the side with the fraction, with the division?
Cancel.
My 9's cancel out. And what does that leave me with?
Plus m.
Good.
Why don't
1.
you multiply it by the top too, if it's like in the parentheses?
So that is an excellent question. Why are we not multiplying the top by 9? So this is really what's happening. Let's break this down a little bit. We have 1 plus m divided by 9. Okay, so it's tough to understand what's happening here since we have a 1 and an m. These aren't like terms, so we can't, I don't know what this number is yet. I don't know what this number divided by 9 is. So instead of me showing you this, let me give you a different number. Let's say 3 divided by 9. Okay, so if I had 3 divided by 9, and I did this times 9, here's what would happen if I multiplied the top and the bottom by 9. So let's see. When I'm multiplying fractions, what's really happening is this is 9 over 1. So let's see. 3 times 9 is what? 27. 1 times 9 is what? 9. Okay. So now let's see. 27 divided by 9. 27 divided by 9 is 3 by itself. So we're really just kind of skipping the steps of doing all of this and having to simplify, figure out what the number is. And I'm showing you, I guess, that whenever you multiply it by 9, you are doing the top and the bottom, but
It's just.
you would have to simplify. You're going to end up, what's going to happen is these do cancel and you get 3 by itself. What's happening here, if I were to take this times, I'm going to use that x for this one, times 9 over 1, I would get, let's see, 9 plus 9m over 9 times 1 is 9. And then these would simplify. You can cancel them out. What would happen is we divide this whole thing by 9. It becomes 1 plus m over 1. 1 plus m over 1. And if anything is over 1, you don't need it. It would just end up being that 1 plus m. So let's see. I'm trying to think of the best way to explain this without getting everybody so lost.
Yeah,
We are multiplying the top. We're just not writing that out because it's extra steps and it makes it super confusing if we don't have our focus is not on simplifying fractions, I guess. It's more so, I normally don't tell you to memorize stuff, but in this case, I feel like I would need to think of the best way to describe it without confusing everyone. Just know that when you multiply this times 9, it gets rid of the 9s. You are multiplying the top, we're just not going to show it. So keep doing what you're doing. Does that answer your question at all?
So whenever it's a problem like that,
Mhm.
instead of timesing the whole thing, you're just timesing 9 by itself with 1.
Over here? Yes. We are multiplying the whole thing. It's just the whole thing on this side is just 1. There's only a 1 on this side.
Yeah. So like what I'm saying is like 1 plus m.
Mm-hmm.
So we don't change anything on
No.
that.
No.
So would it be less confusing for some people if it just went to parentheses on the line on the bottom instead of putting it around the whole thing?
It could be, but I worry in the future that if we are only putting parentheses here, that we might get in the habit of only multiplying the number on the bottom. Because if we're only multiplying 9 times 9 on the bottom here, then we would really have 1 plus m over 8 or over 81. Because 9 times 9 is 81. We are multiplying it by the whole thing. I'm just, I guess, telling you to know or just memorize that if I multiply by whatever number's on the bottom, it gets rid of it in the long run. I'm just eliminating some steps here. Am I stressing you out?
yeah.
I'm sorry. Okay, let's see. If you already understood that when I multiply this by 9, it gets rid of the 9, just know that. The rest, you don't need to know the theory part of it. Just know, if you have something divided by 9, when you multiply it by 9, it cancels it. And you just have whatever's on top left. Okay. 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 We can talk more about it if we want. Let's pause that for a moment, continue solving this. And if we have more questions, we can absolutely come back to it. So we multiply both sides by 9. Cancel the 9s out on this side. So we're left 1 plus m. What do I do next?
Bring down your.
Bring down my greater than or equal to sign. And what next? Yeah, 1 times 9 is 9. So now I have 1 plus m is greater than or equal to 9. What should I do next? Yes, we want our variable to be by itself. So let's get rid of the 1. Minus 1 on both sides. My 1's cancel out. And I'm left with m is greater than or equal to what? 8. 9 minus 1 is 8. So that's our answer for number 4. Write it up here. M is greater than or equal to 8. So how would I graph that?
So have it closed with the right.
Yes, we're going to go to the number 8 and circle it. And then a closed circle. Why are we closing this one? Why do we shade?
Equal to.
Yes, because there's a line under it. It's equal to. It's greater than or equal to 8. So what direction do we shade? To the right. Good. Good. Any other questions about number 4 in particular? Okay. Are there any other ones on this worksheet that you would like for me to go over with the class?
I just have a question.
Yeah, I was gonna say that's the question too.
Yeah. So it's still correct that if you divide by a negative number, you reverse the sign to the right.
Yes.
Okay.
Yes, it is. So which one are you looking at?
It's 5.
Number 5. Okay, let's do 5 together. Now, number 5 is different because we have not talked about this rule. And it's not a rule that I am going to heavily stress just yet, but it is good to be aware of it. Whenever we are solving inequalities, that's what these are, and we have to divide by a negative number at any point. Here's what's going to happen to the sign. Let's see. I'm going to rewrite this problem. We have negative 2r minus 2 is less than or equal to 4. So what would my first step be? To add 2 to both sides. Okay. 2's cancel, and I'll bring everything down. That's negative 2r is less than or equal to 6. Good. So here is the step that we're talking about. Now I have negative 2r is less than or equal to 6. And to get r by itself, I need to divide by negative 2 on both sides, right? So anytime we are solving an inequality and we have to divide by a negative number, only negative number, divide by negative 2, divide by negative 2. When we divide by a negative number, it's going to flip our symbol. Instead of being less than or equal to, it's going to turn in a greater than or equal to sign. It's going to flip-flop it. So we divided by negative 2. That means we have r by itself. And dividing by the negative flips our sign. Now it's greater than or equal to. What's 6 divided by negative 2?
Negative 3.
Negative 3. So let's make a little note. So that's just one extra little rule to remember.
Did it only applies with negative numbers?
Yes, only when you divide by a negative number. That's the one strange exception. Yes.
That's what I wanted.
Yes.
Okay.
So when you divide by a negative number, show that here as well, like that. When you divide by a negative number, flip the symbol. So if it's greater than, it becomes less than. If it's less than, it becomes greater than. Same with greater than or equal to. It becomes less than or equal to. So flip the sign. So we have our answer here. R is greater than or equal to -3. How would we graph that? -3 is the number we're using. Good, closed circle. And which direction do we shape? To the right. So that it's greater than. Okay, let's see if we have another one where we divide by a negative and practice that more. Can I flip this page over? Or does anybody still need this?
Number 9.
Number 9. Yep, number 9 has a negative. Let's do number 9. And that's on the back side. So number 9, I have -7v plus 5 is greater than or equal to -79. So what should we do first?
Subtract.
Good, let's subtract 5 from both sides. What happens next?
Yeah.
My 5s will cancel.
Mm.
And then what?
Be -4.
Which, say that one more time.
Bring down to 7.
Okay, bring down that -7v is greater than or equal to -79 minus 5. What is that?
-84.
-84. Okay. What happens next? Bless you.
You divide by -7.
Yes, divide by -7. And we are dividing by a negative number here. So what happens to our sign?
Okay.
We flip it. So instead of greater than or equal to, what does it become?
Less than or equal to.
Less than or equal to. We're just flip-flopping it. And let's see, -84 divided by -7.
It's 12.
12. Is it positive 12 or negative 12?
Positive.
Positive 12. If we multiply or divide two negative numbers, those negatives cancel out, it becomes a positive number.
So you don't add the 7s on each side?
We don't add the 7s on each side because what's happening here is it's -7 times v, times our variable. So we need to divide to get rid of it, to get v by itself. If it was just -7 with no variable, then we would add 7.
Okay, so the symbol is pretty much multiplication.
Yes.
It's okay.
Yes. Okay, so we have v is less than or equal to 12. So how would we graph that?
Put it 12 close, go to the left.
Good. 12, circle it, shade it in, and shade to the left, less than left. Good. Very good. Very good. There's another negative one on number 13, I think. Do you guys want to run through one more together?
Yeah.
Okay, let's do that. Anybody still need this work on number 9? Anyone have questions on number 9 before we go to 13? Really?
Yep.
That's awesome. The whole thing? Dang. That's impressive. Okay, well, dang it. I'm finding something different to do.
Can we do 16 instead?
16 and 7?
Yeah.
Oh, yeah, 16 looks crazy. Let's do it. Let's look at 16. Okay. And here, real quick. Let me pause this. Okay, number 16. We have a lot going on here. Negative 18 plus k divided by 3 is less than or equal to negative 26. So let's just remember the basics. When we're solving, what do we get rid of first? Addition and subtraction. After we get rid of addition and subtraction, then what?
Multiplication and division.
Good. Multiplication and division. So, what can we get rid of first?
The 18.
The 18. Remember, our goal never changes. It's to get the variable by itself. Variable is k. So get k by itself. And negative 18 is grabbing k over here. We want to get rid of it. So let me write this. Negative 18 plus 3 less than negative 26. Okay, so you said let's add 18 to both sides. Okay. So the 18s cancel. And what happens next? Bring it down, yes, k divided by 3 less than or equal to
Negative 47.
negative, what was it?
44.
Negative 44. If you subtracted 18, I think it might be. But we're adding 18.
I did. I don't know why it's
That's okay. Negative 8. I bet you're right.
Yeah,
I'm gonna double check.
negative 8.
Negative 8. Everybody's getting that? What's 18? Yep, it's negative 8. Okay, so now we have k divided by 3 is less than or equal to negative 8. Yes, now we have k divided by 3. We're going to multiply by 3. On both sides, multiply by 3. All right, and what happens?
The 3's cancel the 3.
Yes, my 3's will cancel.
Now k less than or equal to negative 24.
Yes, k is less than or equal to negative 24. Very, very nice. Then we'll just graph that answer.
I thought that was gonna be like similar to the to number 9.
To number 9. Oh, where we divide by a negative?
Yeah.
It does look like you might because we got 2 negative numbers here. But the only time we're going to be dividing by a negative is whenever we have a negative attached to the variable.
Okay.
So when it's just a number, not on variable, it won't change our answer. Or it won't change the symbol.
Oh,
Yes. Okay, so how do we graph that?
circle 24.
Mm-hmm. Circle it. Do we shade it?
Yeah.
Yes, we do.
You go to your left.
Go to your left. Very, very, very nice. Okay. Any other questions on number 16 in particular? Are there any questions on ones other than 16? Okay. So here's what I think we're gonna do is I am going to set you guys a timer to work on these on your own. I'm gonna be around to help if you guys have questions. And when that timer goes off, we'll look at these together. And then I'll give you an exit ticket. So let me pause this and I'll set a timer for us. Okay, so I am gonna put our exit ticket up and I said it to you, but I'm gonna say it again for the video. After I put up the exit ticket, you are welcome to stay if you would like some more practice, some more help. And if you are feeling good about this, you feel confident, you want to just do the exit ticket, you're welcome to do that as well. So I'm gonna write it out for you. And remember, if you want, I'm going to be making copies of this for anyone that's not here today. So if you would like a copy rather than writing it yourself, just wait and I will make that here in just a moment. Oh my goodness. Focus. Okay, so this is the day 3.
Yeah, no, but you need to reverse it. Oh.
And it's due Friday, January 17th at noon. Okay.
You just try it.
Space for your name.
So you're gonna, you wanna mirror. it.
Okay.
Read this way. It's like you're cross.
So let's see.
First, right? Like here's your variable. So try to make sure that you are.
Number
For instance,
one.
this, make sure it's in there.
I got it.
Do 15 is less than
The one numbers on that.
3 times x minus 6. Say solve and graph the inequality. Uh, Your hand is straight. Okay, just 2 today. That's your exit ticket. So I am gonna end the recording. I'm gonna make copies of this if you need it. And when I come back, anyone that would like more practice on this, please feel free to stay. But also know we will probably be going over more of this tomorrow. And if you'd rather give yourself a mental break, that is fine. I'm not offended. We all could use it. So that is it. I'm gonna end that there and make some copies.